Alright, this is where you should be. Standard S3 is what we're going to be working on starting on Monday. And we're going to do an introduction to this again on Monday using some algebra tiles just to show you a different depiction of it. So that's what this little space is going to be used for. So I'm going to go through and do the steps with you and do some examples. But then the little activity, I kind of need to get feedback from you while we're doing it. So we're going to do that Monday. Alright, so one of the great things about mathematics is that there's many ways to arrive at the same answer. The method can change, and the reason the method can change is because some methods work better than others, but the result will be the same. The standard will be working on the second method. Factoring was the first, of solving quadratics. This method works well with quadratics that cannot be factored, but still have some quote-unquote nice numbers. By nice numbers, I mean like not decimals or fractions or anything like that. Okay, so the method is called completing the square for a reason. But without doing that activity with you yet, you might be able to catch on to why it's called completing the square, but it's going to make more sense when we do it visually. So hang on for that on Monday. Alright, so steps to complete the square. These are the basic steps to this method, just like factoring had steps, like pull out the greatest common factor and then multiply A and C, all those steps that we listed. This method kind of has the same. The thing that you do need to make sure that before you start, just like when you started factoring, you need to make sure everything's over to one side and get it equal to 0. First step is to move C to the other side. Okay, so whatever that C value is, you're just going to move it over to the other side and get it out of the way. Second step is if you have an A value other than 1, you're going to divide everything by A. And then the third step is kind of where completing the square comes in. You're going to take half of B, square it, and whatever that value is, you're going to add it to both sides. What this allows you to do is factor. So we can factor. When you factor, you'll notice the parentheses always end up being the same, so we can rewrite it as a squared binomial. Now, the 4 version, if you look back up at your standard, the 4 version is using this method to rewrite a quadratic in vertex form. So this fifth step is going to have 2 little things to it. If I'm asking you to solve, your next step after doing number 4 is to take the square root of both sides and solve for x. If you're rewriting, maybe you even want to mark that with a 4. Solve for y. Okay, go ahead and flip. We're going to do, I think, we'll do example 1 and example 2, and then we'll do example 3 together as a warm-up. On Monday, we'll do example 4 together today. So, 3 examples. Alright, let's start with 4x squared plus 8x minus 16 equals 0. Alright, so we're going to go ahead and use completing the square to solve this. Because actually this one is not factorable, so we wouldn't even be able to use factoring, so we have to have other ways to solve this besides just factoring. Alright, it's written in standard form. I'm going to start by moving C to the other side. This is the first step. Then I'm going to divide everything by A. because my a value is 4. I'm going to divide everything by 4. So I get x squared plus 2x equals 4. Okay. Then your third step is to take half of b, so half of b is 1. You're going to square that, which ends up being 1, and then you're going to add that value to both sides. You can do whatever you want to an equation as long as you do it to both sides. What that allows us to do now is to factor the left side. Now when we factor the left side, since there's no a term, this is like the shortcut method. X times x would give me x squared, and then the two numbers that multiply to get 1 and add to get 2 would be 1 and 1. These parentheses with this method will always end up being the same thing, which is helpful because then we can write it as a squared binomial, because there's two of them, so we can write it as a squared binomial. And then we've been working on solving equations that look like this. Once your squared term is by itself, you can solve, sorry, this was step 4 here. You can solve this by taking the square root of both sides. If you do that, you get x plus 1 equals plus or minus square root of 5. And then x will equal negative 1 plus or minus square root of 5. Okay, so that's the basic process there. A little hint that I do maybe want you to write down, because it'll help later when we start doing this with some fractions. Whatever half of b was, that's the number in the parentheses. So you see that we have half of b was 1, and then 1 ended up being in parentheses there. That will always happen, and the reason that's good for us to know that that pattern always occurs is because of the next example we're going to do. I'm going to include some fractions, and so it's going to be less cumbersome if we know that that's the pattern. Okay, let's go with I'm trying to think here. 2x squared plus 6x plus, I don't know, 15. Okay, we're going to use completing the square here to solve this. Okay, first step, move c to the other side. Then we're going to divide everything by 2. So we get x squared plus 3x equals negative 15 halves. Then we're going to take half of b, which is 3 halves, because this is like 1 half times 3 over 1, so you'd multiply across on the top and the bottom. We're going to square that, which is 9/4, because you square the top, square the bottom. So 3 squared is 9, 2 squared is 4. And then we're going to add that to both sides. Okay. Now remember, with this completing the square method, once you get to this point, what you've done is you set yourself up to factor the left side. Now if we didn't have the pattern we talked about at the very beginning, it might be difficult, this pattern, where half of b is what goes in the parentheses. It might be difficult to solve this, factor this, because we'd have to think, okay, what two numbers multiply to get 9/4 and add to get 3? Well, whatever half of b was, that's the answer to that question. 3 halves times 3 halves gives me 9/4. 3 halves plus 3 halves gives me 3. So we end up having that situation occurring. And then in order to add these together, I need common denominators. So I have to multiply this by 2 over 2, which would give me, I'm going to do some side work here, negative 30 over 4 plus 9/4. So you get negative 21 over 4. When you add those together. And then I'm going to rewrite this, step 4, as a squared binomial. Okay. And then to solve, you're going to take the square root of both sides. So you get x plus 3 halves equals plus or minus the square root of 21 over 2I, because that negative would have to come out and be an I. The square root of 21 is just 21, or square root of 21, and the square root of 4 is 2. So your final answer here will be negative 3 halves plus or minus the square root of 21 over 2I. Okay. And then let's pull up. We'll do one for example 4. Okay, so rewriting using completing the square. We're going to use the same process here. It's just instead of it being equal to 0 to solve, or at the very beginning, we're going to start with something equal to y. So let's start with, 2x squared plus 10x minus 12. Okay, so we're going to do the same thing. You're going to move c over to the other side. Then we're going to divide everything by a. I'm going to do a little side work over here. I'm going to take half of b, which is 5 halves. I'm going to square it, which is 25/4, and add that to both sides. Okay, doing that allows me to factor the right side. And whatever half of b was, that's what goes in the parentheses. You can also just double check it. 5 halves plus 5 halves gives me 5. 5 halves times 5 halves gives me 25/4. And then I'm going to do my little side work here to add those together. In order to get common denominators, I have to multiply 6 by 4/4, so I get 24/4 plus 25/4. That gives me 49/4. Okay, so we're going to rewrite this as a squared binomial. Now, with rewriting using completing the square, this is where your job changes. Instead of taking the square root of both sides, now I'm going to get y by itself. Because the whole point in this was rewriting something that was in standard form. Now we're going to rewrite it so it looks like it's in vertex form. So I'm going to subtract 49/4 from both sides. And then you're going to divide everything by 2. So you get y equals 2 times x plus 5 halves squared. Then this 2 and this 4 would cross reduce to give you negative 49/2. And that would be your final answer. And if I asked you to find the vertex here, remember your vertex is the value of h and k. So your h is negative 5 halves and your k is negative 49 halves. Okay, we're going to get good practice on Monday on completing the square. You're also going to get good practice on 4 type problems for completing the square and the other 3 standards we've been working on so far. And then we'll review this, work on this, and you'll be set to go for the week. Have a good weekend.